I'm going to just ask Keith quickly. We mentioned that our HVAC best practices guides cover some of the engineering terminology of this, but if you could just let us know, what is this picture that we're looking at here of folks with this chart? We're going to be looking at this chart again a little bit later, and set us up to understand the different types of temperatures and humidities that we're going to be talking about and how those can impact weather.
Well, as we kind of talked about earlier, the dry bulb, the temperature is just what is the temperature of the space, and it has no relative impact with regard to the moisture content that's going to go on. The counter to that one is what we call the wet bulb temperature, and while this is by itself not a meaningful element, when you look at what content is the concentration of moisture in the air coupled with the dry bulb, it now defines a specific point in that chart that you see the gentleman putting their hands up, and to the right is the what we call the psychrometric chart, but that's just our way of plotting where everything goes. And I always hear the word relative humidity, and I just stress the term relative humidity is relative. It tells you nothing. And so unless you know the corresponding dry bulb or corresponding wet bulb or corresponding dew point, you don't know what relative humidity means. But they're all interrelated, and if I know two of the points, I can calculate any other design element that becomes important, including some of the term vapor pressure deficit, and which is becoming more popular within the cultivators. So it's just a way of defining at that state point, this moment in time, I have this much temperature and I have this much water in the space. Therefore, I know the characteristics, and I can understand what type of energy flow is necessary to change that state.